All right, did everybody get a periodic table? Everybody get a table. All right, put your name on it so that if you accidentally lay it down somewhere in here, we can get it back to you. All right, we're going to start a new topic today, and it's going to have a couple different topics on it for the next test. Okay? Now, for those of you who had a really good middle school 8th grade experience, you had a real teacher and had a pretty good teacher. Some of you did. Today is going to be almost entirely reviewed. There will be a couple times that you will learn something new because it's not taught in 8th grade. For those of you who had physical science, today is entirely reviewed. There is absolutely nothing that will be new for you, okay? However, because some of you had a substitute your almost entire 8th grade year, I cannot skip today, okay? And I'm sorry about that. For Baden, I apologize. But unfortunately, half of these folks didn't have the same background you have. Okay, I have another senior here who's had physical science. Who is this? Maybe they're all in 3rd period. I've got multiple people in 3rd who've had physical science, so it must be in 3rd. All right, so if you've already had all this and it's review for you, I'm sincerely sorry. You won't have to hang with us today because there are folks like Tiffany over there who are nodding. Yep, I had a sub all the way through 8th grade. Okay, so she's got nothing. She's coming into this as a blank slate. Okay. Jaden is none, she got nothing either. All right. So, okay, so we got a few people who are blank slates. So those of you who are not, just be patient as we work our way through today, because some of you are going to be like, "Oh yeah, I remember this, Miss Walt. Yeah, I got this." Okay, it's going to come faster for y'all because it's review. And other folks, they're going to be like, "Huh? I don't remember that. I'm aware." So tonight you might have to work a little harder at your homework because it's review for other people in class as we move on tomorrow. Now, when we talk about the atom, okay? All right. First of all, it's the smallest part of an element that can exist alone. If we break it down any smaller than that, it is no longer an atom. It becomes what we refer to as a subatomic particle. Okay? Somewhere in your science background, even if you had a crappy experience, someone probably taught you the 3 parts of an atom. Everybody had this, even if you had a crappy experience. Okay? So tell me what you remember as the 3 parts of an atom. See? Even my girl over there who says, "Yep, I had a sub," remembers this. So, even crappy experiences remember these parts. Okay? Now, you should even remember the charge that was assigned to each of these 3 particles. Okay? Should. Anybody tell me the charge that was assigned to a proton? Mm-hmm. Okay. Neutron.
Neutral.
And an electron. Okay. Now, typically, this is where the crappy experience sort of deviates from the better experience. All right? So, now we're going to build on what you know. I'm giving everybody a chance to catch up. All right. Now, we're going to talk about, in chemistry class, the two parts of an atom. What are the two parts of an atom? Any ideas? Those of you who had a better experience should know this. Okay, you're all yelling out answer once. I give you the hint, I gotta give you the answer.
Go ahead.
Got nothing?
No.
Faith, you got anything? Any recall from this? Give me what you think. Now that I want to put you on the spot or anything.
Actually, no.
Can't remember. All right. How about the nucleus?
Yeah, no.
Remember the second one now that you remember seeing that? Here, I won't even abbreviate it yet. The electron cloud. Now, here is my rant or tirade for the day. Okay? I'm going to ask y'all over the course of the next several months, what parts are found where in the atom? And some of y'all are going to answer this wrong over the next several months. It is my personal pet peeve. It pisses me off every time people do it wrong. Okay? There are how many parts in an atom? There are how many?
3.
Look at their names. Okay? Now, they all have to fit in these two parts. It's called the electron cloud for a reason. What part do you think is found in the electron cloud? Do you know how many people tell me protons are found in the electron cloud on test? Or neutrons are found in the electron cloud? A lot. All right? The only thing found in the electron cloud are electrons. Okay? The only thing found in the electron cloud are electrons. Okay? It's not called the proton cloud. It's not called the neutron cloud. It's called the electron cloud because the only thing we find there are electrons. Okay? So, don't get this wrong on a test. It just pisses me off. Now, by process of elimination, what has to be found in the nucleus then? That's right. Now, based on what you guys just told me, we should be able to figure out the charge on each. What charge did y'all say electrons have? So, that means the electron cloud has what charge? Okay. So, the electron cloud is going to be negative. Now, you said the nucleus have protons and neutrons, right? So, the protons have what charge? Okay. And the neutrons are what? Ooh, they're neutral. So, think math class for just a second. If protons are positive and those are neutral, what charge do you get if you have a positive and a neutral charge? You get a positive charge. So the nucleus will be positive and the electron cloud will be negative because if the neutrons are neutral, do they have any impact on the charge?
No.
No. Okay? Everybody with me so far? Okay. So, okay, that didn't work out so well. Try this again. I'll give you a minute to write that down. Now, the charge, we know, we're just going to assign numbers to them in this chart. Okay? Instead of always saying positive, negative, and neutral, we're going to give them numbers. And the mass will be new for us. All right, we caught up? All right, so if the proton has a positive charge, what number could we give it to represent a positive charge? Okay, so what positive number? Okay, so we give it positive 1. Positive 1. All right, so the electron has what charge? So what negative number can we give it? Fabulous. All right, and the neutron is what? Neutral, so we give it what? 0. Now, we assign these masses also. Okay? 2 particles have roughly the same mass. Any idea what 2 particles have roughly the same mass? Mm-hmm. All right. The proton and the neutron are approximately equal. Okay? So we give them masses of 1s. Okay? They're approximately equal. Now, the electron is negligible. Okay? That word means so small, it's not important. Okay? So, if the electron's mass is so small it's not important, we give it a 0. Okay? So, negligible. That's sort of like, let's say Sophie has a doctor's appointment today. All right, mom comes to get her, takes her to the doctor. The first thing the doctor does when the nurse calls her back to see the doctor is what? The first thing that happens when you go to the doctor?
Check your weight.
They check your weight. Now, Sophie's dressed, right? They make her take all her clothes off? No. Where's your doctor's scale at? Mine is too. Okay? If I feel really lucky, they make me take off my what? Shoes. The jacket because it's wintertime in my shoes. But otherwise, every time I go, I have on what? Clothes. Does it matter that today I have on long pants and a long sleeve shirt versus in July when I go for my yearly checkup, I'm going to have on shorts and a t-shirt? No. The difference in the weight in today's clothes versus my summer clothes is so small, it's not what? Important. Okay? It's negligible. So the doctor doesn't care that I'm dressed differently today versus in my summer clothes. Okay? Is Sophie going to have on the same outfit today that she's going to have on over the summer? No. It's going to vary. The weight of our clothes are going to vary, but not significantly. The mass of the electron is so small, we don't count it in the mass of an atom. Does the electron have a mass? Yes, it has a mass, but it's so small, it's not important. Okay? So don't go anywhere and tell your college professors if you take chemistry that I told you the mass of an electron didn't exist. They have one, it's just really, really tiny. Now, have any of you ever been to the doctor and seen a baby weigh? Yeah. Do they have on clothes? Yeah. Why not? Anybody know why? How much do we weigh? A lot more than a baby. So a baby, when you consider, let's just say they have a diaper on, that's a significant part of their body weight. Let's say we weigh 130 pounds when we go to the doctor, or 150 pounds when we go. Our clothes are a very small amount of our body weight, maybe a couple percentage points. But if you only weigh 10 or 15 pounds and you have a wet diaper on, That could be 10 or 15% of your overall body weight. That's huge. How do they decide what prescription of medication we get? How do they decide how much we need? By weight. So if your diaper is wet, when they weigh you, they could prescribe the wrong medication for you, and they could either give you not enough to get well or give you too much and poison you or kill you. Okay? So it's important to know how much you weigh. But our clothes are not important for us. All right. So from there, in 8th grade, if you had a good experience, you learned about 2 words on the periodic table. Okay? There's 2 numbers on that periodic table. Does anybody remember what those things were called? Both of them. They each have a name. I'll take either one. Nope. Hold that thought. Inside the actual box. That's one. Anybody got the other one?
No.
There you go. That's both of them. All right. So one we're going to talk about today is atomic number. And the other one is atomic mass. All right. So now that we have the numbers, or the names of the numbers, can anybody recall what either of those 2 things did? Anything ring a bell? Remember what they had to do with? No. Okay. The atomic number tells the number of protons. If I can spell it right. In an atom. Okay. Atomic number tells the number of protons in an atom. Now, atomic mass tells the number of protons and neutrons in an atom. All right, we all there? All right, so if we have, nope, let me go back.
Oh.
Okay. So if we have all right, which one of these is the atomic number?
Person.
Okay. How do you know? How do you decide? All right, which one's less? Okay, the 14 is less, yes. Okay, the atomic number is less. All right. This is the number, and this is the mass. All right, so y'all were right about that. Now, how are you going to know that? Okay, how do we know that? Look at the definition. I'm going to flip back a page and I'll come right back to this.
Mass is protons and
That's right. This means what? What does the word and mean in math class? It means add, okay? This is a combination of 2 particles. All right? So, just is something, don't ever write this down as an answer. All right, but this is just a shortcut to help yourself. The atomic mass is always the big number. Always. That means the atomic number is always the what? It's always going to be the small number. That never changes. So when you look at a problem or on the periodic table, the little number or the small number is always the atomic number, and the atomic mass is always going to be the large number. The atomic mass is always a combination of protons and neutrons together, so it always has to be that big number. Does that make sense? Okay. So that's how we knew the 14 was the number and the 28 was the mass. Now, a lot of times people want to say, oh, the 14 is the atomic number because it's on top and the mass is always at the bottom. Does the periodic table have to be laid out that way? Now, if you look at this one, the atomic number is on the top. But if you look at this one, the atomic number is where? It's on the bottom. Okay? So atomic number can change in location depending on the design of the periodic table, which is why I'm telling you atomic number is always the small number and atomic mass is always the what? Big number. Now, odds are good that your middle school teacher only used the periodic table. They probably never taught you the notations that you have to know how to use. So that piece will be new to my class. Unless you had physical science, you probably don't know hyphen and nuclear symbol notation. Okay? Okay, good. Good. All right, everybody caught up? All right, we're going to start with nuclear symbol notation. Which students tend to like the best because it has both numbers in the notation. I like the other one easier because it's easier to type. So, nuclear symbol notation would be something like this. And it's called nuclear symbol notation because it has the symbol in the notation. Okay? Cl is the symbol for an element. Now, while we're talking about symbols, if it has two letters, the first letter has to be what? Capital, and the second letter has to be, make sure you write it that way. We'll really emphasize that in a couple days when we do naming. Okay? But make sure you write it correctly. So, to find protons, how are we going to find protons? Protons are the what? Okay, can we be a little more technical since we're in a chemistry class than saying it's the bottom number? Okay, other than saying it's the smaller number. Use the vocabulary we've learned. I'm not saying you're wrong. I just want you to use a vocabulary word that we've learned. There you go. I like that so much better. Okay? Protons are always the atomic number. Okay? That's the definition. Protons are the atomic number. Now, there's nothing wrong with knowing they're the little number. But again, that is for you in your head. Are we ever going to write that down or say that answer as an answer on anything? No, that's just for you. So, what is the atomic number? So that's our number of protons. We have 17 protons because the atomic number is 17. Now, I have not mentioned electrons at all, have I? Because they're not given in protons, or I mean in atomic number or atomic mass. They're not defined, are they? Huh. How on earth are we going to know anything about electrons then? Hold that thought. Don't subtract to get electrons. How are we going to know electrons? How do you know that, Thomas? I don't know.
Oh, because they got like the same mass. You said they're the same. I said
okay, why?
Because they're the same mass. They got the same. You said they're equal.
They have to be the same if there's one has more, it has to balance or something.
You're not far off. An atom has to be what? Neutral. Has to be neutral. Yeah. Okay. So let me cruise back here for just a second so we can write it down. I can use red. An atom is what we say is electrically neutral. So, if it's electrically neutral, the number of protons must equal the number of electrons. Right? The number of protons have to equal the number of electrons. They have to be equal. Otherwise, it's not equal. The atom is charged. And we're going to talk about an atom that's charged really close to the end of class. Okay, but right now, the atoms are neutral. We're going to talk about some that are not equal at the end of class. But right now, they are equal. Have I given everybody enough time? All right, so if we know they're neutral, what do we know about our protons and our electrons? They're the same, okay? So same as the protons, so there are 17. All right, now for neutrons. I told Justice to hold that thought. So now let's go back to what Justice said a second ago. Okay. So way back in his archives, he remembers to find the neutrons that we subtract mass minus the number. Now, the reason we do this, if we label this 37 is the protons and the neutrons, right? And 17 is just the protons. Now, what happens if we do what Justin said and we subtract these? What's going to happen? Yeah, I know we're going to get 20. I can subtract. Tell me what's going to happen when I subtract them. That's the word I was looking for. The protons are going to cancel out, and I'm going to get 20 what? Neutrons. Okay? So, when I say 37 minus 17, I get 20 neutrons. But the reason we subtract these is so the protons will cancel each other out. That's the purpose behind it. Okay? Does that make sense? Okay? I'm much more interested in why than I am just do this because I said so. But I just wanted you to do that. All your tests would be what kind of tests? Yes. All right. You with me on it? All right. So the second notation we're going to do is called hyphen notation, which I like better because it's much easier to type. Such as iron-56. Now, this only gives you how many numbers? You've got to find the second number. Now, which number do I have to provide? I have to provide the mass. Okay? The mass must be given. You can look up the number on the periodic table. Now, why can you look up the atomic number? The atomic number never what? It never changes. Okay? The atomic number never changes. It identifies the element. If you look up carbon, carbon's atomic number is always a 6. It never, ever changes. Mass can change. Called an isotope. We're going to talk about that in a few minutes. Okay? So, if we look up iron, it's in the middle of the periodic table. Find iron's atomic number. It's in the middle. Did you find it? It's in the middle.
26.
Okay? Now, for those of you who are wondering why it's Fe, iron's Latin name is ferrum. So, the first two letters in its Latin name are iron or ferrum or Fe, which is why we use Fe and not IR. Okay? So, its atomic number is 26. So, if I ask the protons, all right, how many protons would I have? How many electrons would I have? Because they have to be the same. How would I find the neutrons? Are we okay on that? Yes? No? Okay. Now, what if I want to go backwards? Suppose I tell you that you have 34 electrons and 45 neutrons. And I want you to write nuclear symbol notation. Can we do it? What would we need to do first? Why? Why would we add them?
Because on the mass, you needed both the protons and the neutrons.
Okay, so Andy wants to find the mass. We have Samaria finding the what? All right, so Samaria wants to find the protons. So the protons are what, Samaria? All right, so the protons are 34. All right. Andy wants to find the mass by saying 34 plus the neutrons, which are 45, which would give us what, Andy? All right. So, do we need anything else to be able to write this in nuclear symbol notation? What else do we need? You've answered no. Sure. All right, I got two. All right, the symbols. Okay. What would I use to find the symbols, Tomas? The atomic number. Okay. So the atomic number is 34. Okay. So somebody tell me what element we have. Somebody other than Samaria, Tomas, and Andy. What? Selenium. Okay. So we have selenium, which is abbreviated SE. All right, so to write nuclear symbol notation, I write SE. What has to go at the top? Okay, so what's my mass? And then what goes at the bottom? Which is? Questions about how we did that? Yes or no?
Doesn't matter which side the little numbers go on.
No, if you'd put them on this side, I'd have been fine. Typically, we put them on the left because we're going to do ions a little bit, and we're going to put the ions on the right. So typically, we put them on the left. Okay? Now, the last thing I want to talk about before we practice is the word isotope. Okay? Everybody got what they need? All right. So what is an isotope? Anybody know? You've heard the word, used lots of times in other science classes. So what is an isotope? Anybody know?
Using isotope, maybe isolate.
Mm-mm. It has the same number of protons and a different number of neutrons. Now, some textbooks define it differently. They say same atomic number, different atomic mass. Those are the exact same definitions. It doesn't matter which one you use, they mean the same thing. Okay? Whether you say same number of protons or you say same atomic number and protons are the same thing. The sooner you commit that to your brains today and tomorrow, the easier this concept will be. But atomic number and protons are one and the same. You need to be able to use those words interchangeably. Now, atomic mass changes because you have a different number of what? Neutrons. If the neutrons are different, the mass changes. Now, the example I always like to use for this is carbon. Carbon 12 and carbon 14. Now, if you look on your periodic table, how many blocks for carbon do we have? 1. So we can only put how many masses on the periodic table? 1. We can't put both of those masses on the periodic table. So the mass on the periodic table is an average. Okay? And we're going to talk about how to average those two masses most likely tomorrow. Okay? I doubt we get to it today. Getting up there on number 6 on the agenda is a pipe dream. All right? So we're going to talk about how that number that's on the periodic table is done tomorrow. However, there's actually carbon 13 also. How do we decide which one goes there? First of all, where do these numbers come from? Well, we know the protons all right, how many protons does carbon have? I have failed y'all. How many protons does carbon have? How do we find that out? I could not hear that mumbling. We look on the periodic table and we find the what? Yes, we look up the atomic number. And the atomic number for carbon is 6. So there are 6 protons. 6 protons. How many electrons are there? Because they have to be the same, right? Now, how do we find the neutrons? We subtract. 12 minus 6 is, don't pay attention to the numbers. All right? 14 minus 6 is, so the difference of these two is here. Are these things the same thing? Anybody know the difference between carbon 12 and carbon 14? Anybody know what carbon 12 is? All right. Here's my second tirade for the day. And you're going to hear me lecture y'all all year about this. Because people will ask me for this, and I lose my patience. I do it to my son every night. He did it to me last night, too, at dinner. When he brought his pencils out. What are y'all writing with? Y'all are writing carbon. Okay? When y'all say you're writing with graphite because you're trying to make your science teacher happy, y'all are writing carbon. Okay? Those nice pencils y'all are writing with, writing carbon. They took lead out of pencils in the 70s. Because lead's toxic. If I got pissed at Sophie and jabbed her with my pencil because she made me mad on the bus lot, and that piece of lead broke off in her arm, she could wind up with lead poisoning. Okay? So way back in the early 70s, They took lead out of pencils. So now if she makes me mad on the bus lot and I jab her with my pencil, I'm leaving a piece of graphite in her skin. Some innocuous carbon. It's not going to hurt. Might not look very attractive in her skin, but it's not going to hurt. Okay? So when you walk up to Sophie and say, can I have a piece of lead? You're not getting any lead. That stuff is carbon. It's carbon now. It's been carbon for darn near 40 years. Stop asking your classmates for lead. There's no lead in pencils. It's carbon. It's graphite. It's not been lead for 40 years. Your parents, your grandparents, you will perpetuate that myth onto your children because y'all have been asking for lead your entire lives. It's not lead. It's carbon. Okay? My son stood his sanity every time he said, Mom, you got any lead? No, I don't. It's carbon. We don't have lead in the house. Okay? It's just some graphite. It's carbon 12. Now, what's carbon 14? Anybody know? Baden's tired of hearing me go off about that. Don't ask anybody for lead in my classroom. Because I'm still going to tell you no. Then I'm going to correct you. All right, carbon 14. Any ideas? Should we talk about nurse science? No. You think nurse science? No. Okay. Carbon dating? Any ideas there? What did I say, carbon dating? Huh? Some rocks? Some fossils?
Oh, I remember that. Yeah.
All right, check how old the rocks and the fossils are. The dinosaur bones? Y'all remember any of that now? Okay. All right, if you want to know how old some rocks and dinosaurs, some fossils are, carbon 14 is a radioactive element that will decay over time, and you can find out how old they are. Okay? It's a radioactive element. Now, carbon 12, a graphite in your pencil, is a radioactive. Okay? They are not the same thing. One of them is radioactive, one of them is not. They're isotopes of each other. They are not the same thing, however. They each have the same number of protons. They do not have the same number of neutrons. Okay? Now, the reason I bring that up, suppose, just for a minute, that on the quiz tomorrow, you have a question. And it says, let me write it out this way. This one always creates more issues. Let me see what the actual number is. It says, I write it this way. Now, look at manganese. Middle of the chart. Look at manganese, middle of the chart.
Amen.
Yep, Mn. All right? And I want you to find the protons, the neutrons, and the electrons. All right? How many protons are there?
24.
Everybody agree?
25.
I'm glad we fixed that. Okay? 25 protons. All right, so how many electrons would there be? Okay. Now, to find the neutrons, how do we find the neutrons? All right, 57 minus. Now, what do you suppose the question is I get often? Okay, what's the question? That's the question I was hoping for. Thank you very much. Okay? People look at this and they go, this wall. This says 57. How'd you get that 57? Because Jade's looking at this going, it says 55 on the periodic table. It says 54.9. That's the 55 in my world. And you wrote 57. This is an isotope. This is the average on the periodic table. Remember, we can only put how many numbers on the periodic table? How many numbers can we put up there? How many numbers can we put on there? I'm talking about just the mass, people. Just the mass. How many masses can we put on the table? One. Okay? Sort of like your report card. When you send home your report card grade, we can send home how many? One. So we have to do what with all those grades we put in there? We got to average them and just send home 1. Okay? So we take all the isotopes and we have to do what with it? Average them to get 1 mass. So this is the isotope I want you to use, and that's the average that's on the periodic table. So when you do a question, you use the number that I gave you. That's just the average that's on the table. So sort of like yesterday you got a test grade, but is that necessarily the grade that's going home on your report card? No. Okay? So you use whatever I gave you in the question. Does that make sense? Okay. You think you can practice some of this before we talk about ions in a little bit?
Yeah.
Okay. Darling, wake up.
Girl, Bob.
Just finished it.
Adam.
All right. Find me the answers.
Dating.
Have a question for me? Got a chance to get started. Anybody stuck? Anybody? Hey, that's no. This one. What? No, it was. Yeah. All right, how many of you are still working? Anybody? Got them all? All right.
I told you not to leave me alone too long, I'd be reading.
All right, so how many protons you got in that first one? All right, how many electrons? I'm just going to write 11, 11, and all right. So number 2 or B? And all right, so protons? Okay. And protons? Electrons? And neutrons? All right. Does anybody have a question about any of those 4? How we got them, what to do, any of those? You will have a quiz on this tomorrow. So does anybody have a question on how to do those?
No.
Okay. So in the bottom ones, all right, you had to write hyphen and nuclear symbol notation. So what element do we have in A? Silicone or silicon. You can say it either way. So Si, and you have to write it down as silicone or silicon. All right, so atomic number is 14, so it needs to go at the bottom, and 28 at the top. Now, if you flip those, I would not penalize you for that. Okay, I would not take off for that. Now, what has to go at the end of the one that's hyphen notation? The mass. Okay, so those are your 2 answers for A. Questions about those 2? All right, so in B, this time you got to do a little more work. They didn't just flat tell you number and mass. You got to figure them out. So what is the number in B? All right, how do you know the number is 26? What's always the number? That's right. So the number is 26, and we need to figure out the mass. So how do we figure out the mass in B? Add them. So 26 plus 56 or 30 is 56. All right. So what tells us the element in B? The atomic number. So this 26 tells us is what? Iron. So Fe, and you got to write out iron. All right. So again, should be the mass at the top and the atomic number at the bottom. But if you had it flipped, I wouldn't penalize you for that. And what goes at the end? 56. All right. And then the last one, you got to find it again. So we need the atomic number and we need the mass. So what's my atomic number in C? 56. And to find my mass, I do what? So 56 plus 82 is 138. So what's my element? All right, it's pronounced barium and Ba. So Ba has a mass of 138 at the top, 56 at the bottom, then hyphen 138. Questions about how to do any of those? Yes, no? Anybody? Because we have one more thing to do today. All right. So the last thing we're going to do today is talk about ions. All right. Ions are atoms with a charge. Now, there's 2 kinds we're going to learn about. We're going to talk about cations, and you're going to hear me use these names quite a bit over the next couple months. And every time I say them, half of you are going to swear up and down I didn't use them. Okay? Cations are positive ions, and anions are negative ions. As we cruise through the semester, we're going to talk about why. But cations mean that you lost electrons. Anions mean that you gain electrons. Now, not going to spend a lot of time on that today, other than to say that's what it means. Cations mean that you lost electrons. Anions mean that you gained electrons. We will talk about the whys as we go through the semester. Okay? Now, we want to be able to find protons, neutrons, and electrons if we have something like this. That's an ion. How do you know it's an ion? It says +3 on it. Okay? That +3 right there says to you, I am an ion. Now, if I'm an ion, my protons do not equal my electrons. Okay? My protons and my electrons will not be equal. Does that make sense? Okay. Now, we want to be able to find our protons, our neutrons, and our electrons just like we did in the practice problems you just did, even though it has a +3 on it. Okay? Now, the important part is this right here. If you're a cation, it means you did what? Lost. So if it says a plus sign, it means you lost. So this +3 means you did what? You lost how many? 3 electrons. If you have a minus, it means you did what? You gained. That's the piece you have to remember. So I'm just going to rewrite this one over here. So we had Fe with a 56, a 26, and a +3. All right, so we're going to find our protons, our electrons, and our neutrons, just like we did a little while ago. So to find our protons, how did we find our protons for the last half hour, 45 minutes? Still the atomic number. So how many protons do we have? 26. Now, how do we find our electrons? Okay, hang on before we do that. All right. It's the same as the protons. So we know that it's 26. Now tell me what you're getting ready to say. Now we have to do what? All right. Now we take this 3, okay, and we lost 3 electrons, which means we're going to subtract 3, which will be how many? 23 electrons. Now, the last thing is neutrons. Does that +3 do anything to the neutrons? No. So how did you find neutrons a while ago? You still say mass, subtract number. So 56 minus 26 is 30. So that +3 only impacts what answer? The electrons. It doesn't change anything else. Okay? Does that make sense? Now, can we go backwards? If I give you some numbers, can we write that? Yeah? Okay. So if I say something like you have 18, no, that's a noble gas, 19 protons, 18 electrons, and 20 neutrons. Can we write its symbols? Same way, the nuclear symbol. Okay, what would we need to do? What would we do if this was on our quiz tomorrow? Tell me the process. What would we need?
Find it.
Find what? Okay, what would I use to find the element? Justice.
Atomic number.
Okay, so what's my atomic number?
19.
All right, so the atomic number is 19. So what's my element then? My element is potassium. Now, my element is potassium, which is K. Now, a lot of you, again, had a nice, sound 8th grade experience, had lots of practice with the elements, and so you know potassium is a K. Some of you will rush to go, oh, potassium. Potassium is a P, and write a P down. P is phosphorus, okay? And I reiterate that when we do naming. If you put the wrong element down, it's automatically wrong, okay? So make sure if you didn't have the best experience and you don't know the elements and their symbols very well, look them up, okay? A lot of people give tests, make you memorize this stuff. I don't do that. There are 2 full-size periodic tables hanging in here. I just handed you one. These will not be covered until the day you take the exam, okay? They will not be covered. I handed you a periodic table. If you need the symbol, you need to do what? Look it up. But if you don't look it up because you're like, I know it, you just write it down, and it's wrong. It's just wrong. I just marked it wrong, okay? So, K. So we got a K for our symbol. What do we put where? Protons, 19 go at the bottom, all right? So we got our 19 for our atomic number at the bottom. All right, what goes at the top? We don't put 20. What needs to be at the top? We need a mass, right? What makes up the mass? Okay, so the mass is always the protons and the neutrons. So how many protons do I have? Plus, what's my neutrons? So that's going to be what? So I'm going to put 39 there. All right, so how do I get, if I need a charge, if I need a plus or a minusy thing? How do I decide? Okay, I got several people yelling the right answers. How'd y'all decide? Okay, when I look here, what can y'all tell me about the protons and the electrons? Okay, a couple people said they're not the same. That was the first thing you should notice, okay? And then these guys would say it's attractive. That was a great answer. Okay, 19 minus 18, they said was 1. That was great. All right? Now, who's bigger, the protons or the electrons? What's the charge on the protons? That's how you know it's a plus. The protons are bigger, it's positive, put a positive charge on. Does that make sense? Okay, everybody with the folks over here who are doing it right? Yes? All right, we're going to do 2 short questions while I hand out homework. I know, homework. I want to do, let's do number 2 and number 4. 2 and 4. Well, I hand out homework. And I'm going to tell you what to do on this one and the next one in just a bit, because we're not doing all of it on either one of them. All right, so we look at number 2. How many protons you got? How many electrons do you have? All right, so you got 34. And this little -2 means to do what? Add 2. So that's how you get 36, because it means you gain 2. And to find the neutrons, you said 79 minus 34 is how much? 45? Okay. To do number 4, this tells us the element, right? So what element was it? Phosphorus. And it tells us the atomic number is 15. How many protons and neutrons do we have to make up a mass? 15 plus 16 is 31. So there's our mass. Now, what can you tell me about protons and electrons? Are they equal? So 15 plus 18 is not equal, so we subtract, we get, so 3. Who's bigger, protons or electrons? What's the charge on electron? So -3. All right, for homework, the sheet that has the chart. The sheet that has the chart. We're doing 1 through 10. Okay, 1 through 10. The back side, we do not know how to do. I'm saving paper. That's for tomorrow. Leave it be. Okay, 1 through 10. On this one, we're doing 1, 3. No, we're not. I need some negatives. We're doing the odds. No, we're not. I need some negatives here. Apparently, all the negatives are evens. All right, let's do 1, 2, 6. 1, 2, and 6, 7 and 9. 1, 2, 6, 7, and 9. Okay, on this sheet. Everybody got me? So 1 through 10, 1, 2, 6, 7, and 9. And that's your homework. I will be here today if you want to do test corrections or you need help. One, 2, 6, 7, 9. All right, put your calculators in the tub.